Very good. Welcome, everybody. So today we're going to talk about using trig identities. Using trig identities. Well, so let us begin. Remember, we start talking about trig functions, am I right? We said that we have a sine of an angle. That angle can be theta. It can be, for example, sine of alpha. In general, it can be sine of x. And then taking the sine and then the cosine functions, we build some new functions out of those. We said that, hey, the tangent is sine over cosine, and if we flip that, we create a new function cotangent, which is cosine over sine. Then we say that, hey, let's flip sine and define cosecant. So this guy is 1 over sine theta, and if we flip cosine, we get secant of theta. Very good. Now we're going to just review about trig identities: sine squared of theta plus cosine squared of theta, which is always equal to 1. We saw a very short proof using the definition of sine and cosine by a right triangle. Remember that when you have a right triangle, here you have x, here you have y, and here you have the hypotenuse. And using these definitions for sine and cosine, we saw that sine is nothing but y divided by r. So y over r squared plus cosine x divided by r, x over r squared. If we simplify this, you get y squared over r squared plus x squared over r squared. Now, if you take the common denominator between these two, you're going to have r squared, and the numerator you have x squared plus y squared. But by using the Pythagorean theorem, on the numerator you have your r squared. R squared over r squared is equal to 1, which is equal to the right-hand side of your equation. With the same logic, remember that we talked about 1 plus tangent squared of theta, which we saw it is equal to secant squared of theta. Another identity was 1 plus cotangent squared of theta, which was equal to cosecant squared of theta. Very well. Now we're going to use what we defined before and try to simplify more expressions. When you simplify expressions, it helps you to solve equations much more easier. Let's cover one example. So the question says, factor each expression. Okay. Factor each expression. We're going to go back and forth between whatever we learned in algebra and try to factor out the following expressions. The very first one says, well, you have secant squared of theta minus 1. Okay, well, what I learned from algebra was that in algebra, I have, for example, x squared minus y squared the difference between two squares, I could write this in factor form, which was x minus y times x plus y. This is what we learned from algebra, right? Also, we learned that if you have x squared minus 1, this can be written as x squared minus 1 squared. X squared minus 1 squared. 1 times 1 is always 1. So this guy can be written as x minus 1 times x plus 1. What we learned from our algebra, right? So compare x squared minus 1 with secant squared of theta minus 1. We can write this as secant squared of theta minus 1 to the second power. So in a sense, you can say, hey, this is my x and this is my y, and I can follow what I have before from algebra. This can be written as secant of theta minus 1 times secant of theta plus 1. Remember that, guys, another reminder. Secant squared of theta is nothing but secant of theta times secant of theta. It's different from secant 2 times theta. This guy says, hey, my variable is theta and I'm multiplying my variable by 2. This guy says, hey, I have a function which called secant of theta. Now I multiply secant of theta by itself and I put exponent 2 on top of it. When you have secant to the power 2 of theta, it's equivalent to writing secant of theta to the second power. But by convention, they prefer to write it this way. They have the same meaning. Perfect. So let's move on to the next expression that you want to write in factor form. So the second expression says, okay, you have 4 tangent squared of theta plus tangent of theta minus 3. Ooh, I have a quadratic expression. Guys, there is no equality on the right hand side. It's not equal to 0. It's not equal to any number. It's not an equation. This is just an expression. We want to write this expression in factors form. Well, let us go back to algebra. From algebra, I know that, for example, 4x squared plus x minus 3 can be written in factor form as, well, 4x minus 3 times x plus 1. Okay. Where did this come from? How do I get this factor? Okay. One method in going back to algebra was to write this expression in 3 terms into 4 terms and use factoring by grouping the terms. Factor by grouping. Okay, how does it work? Take a look at this. Here I have 4x squared plus x minus 3 equal to 0. I need to break down the middle term into the sum of 2 terms. So take a look at this. I'm going to copy down my first term, 4x squared. I'm going to copy down my last term, which is negative 3. Well, the middle term can be written as, okay, let's see, what do we have here? Let's see, we need to figure out how we can break this down. If I write this as, let's see, 4x minus 3x, let's see if it's working or not. So, okay, so if I factor out 4x, I left with x plus 1, and between these two, if I factor -3, I left with x plus 1. So now between these two, I can factor out x plus 1. So I left with 4x minus 3 times x plus 1. This method is called factored by grouping. Another method is using quadratic equation. Well, okay, that sounds interesting. How does it work? Quadratic equation. So what they do, they create an equation and solve it. They say that, hey, suppose we have a quadratic equation and let's solve it. So remember that in quadratic equation, you have x equals to -b plus minus square root of b squared minus 4ac divided by 2a. Okay, it's not that hard. You can easily identify a, identify b, identify c, and then plug them in. X is equal to -b, -1, plus minus square root of b squared, 1, minus 4 times -3, and then divided by 2 times a, which is 2 times 4. Very good. So x becomes -1 plus minus square root of, well, let's see. I have 16 times 3, 48. So I have 48 plus 1 becomes 49. Okay, divided by 8. So my x is equal to -1 plus 7 over 8, and x is equal to -1 minus 7 over 8. So take a look at this now. X is equal to 6 divided by 8, and x is equal to -8 over 8. X is 3/4, x is -1. So if I bring this next to the x, I get x plus 1 equal to 0. If I multiply this by 4, I get 4x equals to 3. If I subtract 3 from both sides, I get 4x minus 3 equal to 0. Take a look at this. 4x minus 3, x plus 1. I found the factors. Both of these methods are absolutely legible. So as you can see, here you have a trigonometric expression, but we are all going back to algebra to use the skills that we learned before and solve for what is asked for us. For example, here it just says factor the expression. So we're going to write this kind of factored form, and later on in the rest of the chapters, we're going to learn how to solve this trigonometric if you have equality on the other side. For now, our main focus is to write this in factored form. So going back to algebra, we know that 4x squared plus x minus 3 can be written as 4x minus 3 times x plus 1 using either grouping method or quadratic equation method. So identify your x. X is equal to tangent theta. So this guy can be written as 4 times x. X is tangent. 4 times tangent theta minus 3 parentheses x is tangent theta plus 1. So we wrote these two expressions in factored. Very good. Let's take a look at another example. This example says, well, now work with this expression. You have cosecant squared of x minus cotangent of x minus 3. Okay, how do I write this in factors? Okay, can I apply quadratic formula here? Guys, note that we cannot use quadratic formula yet. Why is that? Because in quadratic formula, you have a, for example, x squared or u squared, whatever you want to use, a u squared plus bu plus c equal to 0, and u was negative b plus minus square root of b squared minus 4ac divided by 2a. U is your variable. You can replace it with theta, you can replace it with b, but you must have the exact same variable here. You can use x, any variable is acceptable here, but they must be the same variable. If you're using x squared here, you need to use x to the first power here. If you're using u squared here, you must use u to the first power here. You cannot have u and then v. They must be the same variable. So take a look at this. You have cosecant squared minus cotangent. Cosecant and cotangent are different from each other. So we cannot use quadratic formula yet. So what's the remedy for that? You need to convert cosine somehow into cotangent. Well, we know that cosecant squared of theta is equal to 1 plus cotangent squared of theta. Choose x or theta, it doesn't matter. Number right, we learned about this identity, trig identity. So now wherever you see cosecant squared, replace that by 1 plus cotangent squared. So your expression becomes 1 plus cotangent squared of x minus, now just copy down cotangent of x minus 3. Here you have two constants, combine them. This guy becomes cotangent squared of x minus cotangent of x minus 2. Well, now factor this. Factor this expression. This expression is equivalent to this expression. They are the same thing, another representation. So, okay, how do I write this in factor form? I'm looking for two numbers. Their multiplication is -2 and their sum is -1. So if you have from algebra, if you have x squared plus bx plus c, you can break this guy down as x plus m times x plus n, such that the multiplication of m and n and their sum has to do with the elements here. Remember that. To break this guy down, you're looking for two numbers. Their multiplication is -2 and their sum is -1. So their multiplication is C and their sum is B. This is from algebra. So what are those two numbers? -2 and -1. What are those two numbers? Cotangent of x, cotangent of x. We're looking for two numbers. The multiplication is -2. Their sum is -1. Multiplication -2, and their sum is -1. What are those two numbers? -2 and 1. So you get cotangent of x -2, cotangent of x -1. Is that correct? Or should I use +1? Am I correct, class? Very good. Awesome. So we wrote this expression in factored form. Cosecant squared of x minus cotangent of x -3. First of all, you need to have the same function here. Otherwise, you cannot write it in factored form. That's why we use trig identity. 1 plus cotangent squared equals to cosecant squared, and replace that here. Now, these two are equivalent to each other. This expression, original expression, is the same as the simplified expression here. From algebra, if you have x squared plus bx plus c, you can write it in factored form, but you're looking for two numbers. Their multiplication is equal to c, and their sum is equal to, by doing a basic algebra, you can find m and n as -2 and +1. So just substitute them here. Here you have cotangent of x -2, cotangent of x +1. There we go. Next example for you. Erase these. So now question says simplify. Simplify as much as you can. So in previous question, we had factoring. In these questions, we have simplify. Simplify the expression. Okay, simplify the expression. Well, what is the expression? The expression given to me is sine t plus cotangent t, and then cosine t, doesn't matter. Cosine t times cotangent. Okay, well, I have sine plus, then I have multiplication. Guys, from algebra, remember that multiplication comes first. It means that these two are attached together. It means that you have to do the multiplication first, then do the addition. Well, okay, let's see what I can do here. Well, we know that cotangent is cosine divided by sine. Okay, I have something to work with. Well, I'm going to copy this guy down as sine t plus, I'm going to copy down my cosine t, and now I'm going to write down cotangent t as cosine t divided by sine t. So think about it this way. Here you have a plus b times b over c. So try to imagine the very simplified version of what you have. Suppose you have this fraction and you try to simplify this. Okay, here you have b and b. b times b is b squared. All right, so you can write this as a plus b squared divided by c. Okay, step by step. I'm going to copy down my sine plus cosine times cosine is cosine squared of t divided by sine t. Well, now what? I have a, the denominator is 1, invisible denominator is 1. What should I do? I need to create the same c on the denominator. So it's going to be a c divided by c plus b squared over c. Okay, it's not that hard. I can do that. The denominator here is 1, so I need to have the same denominator here and here. So I'm going to multiply the same numerator and the denominator by sine t. And I'm going to copy down plus cosine squared t divided by sine t. Very well. Okay. I have sine times sine, which I already know that is sine squared of t divided by sine t plus, I'm going to copy down the second fraction, cosine squared of t divided by sine t. Hey, they have the same denominator. So I can write down one denominator and write the numerators next to each other. So this guy becomes sine squared of t plus cosine squared of t divided by sine t. Hey, but I know from trig identity, this is just 1. From trig identity, my numerator is nothing but 1. 1 divided by sine t. Hey, we already defined 1 over sine t. This is cosecant. So this is your algebra part. Using algebra to help us simplify this expression here. So let's take a look at another cool example here. To simplify what we have, let's make it more interesting. So the second one says that. What does it say? It says number 2. Now you have sine theta over 1 plus cosine theta plus cosine theta divided by sine theta. Well, what do I have here? This is new. I have different denominators and I have a crazy looking denominator. Don't let it scare you. This is just simply a over b plus c over d. Well, in this case, if b and d have no common factor, it's going to be ad divided by bd plus cb over bd. Now you have the same denominator. You're going to write it as ad plus cb over bd. These two fractions are both the same behavior. Well, okay, from algebra, I know this is what I should expect. So I'm going to apply what I learned from algebra to trig. These two have no common factor. This is just 1 plus cosine. It's a crazy looking function. And I have sine, which is my periodic function. So what I'm going to do, I'm going to multiply the first fraction by sine, multiply the second fraction by 1 plus cosine. Guys, take a look at this. And multiply the second fraction by b. So here we go. Sine theta times sine theta divided by 1 plus cosine theta times sine theta plus. Now I'm going to multiply the second fraction by 1 plus cosine theta. I get cosine theta times 1 plus cosine theta divided by sine theta times 1 plus cosine theta. Okay, so far I'm here in this step. There you go. Now they have the same denominator. I just write one denominator, which is sine theta times 1 plus cosine theta. And then just take a look at this. This is sine times sine. Well, sine times sine is just sine squared of theta plus plus. Well, guys, from algebra, we can distribute cosine into the binomial expression here. So you get cosine theta plus cosine times cosine, cosine squared of theta. Well, okay. I have a sum of sine squared plus cosine squared. This is nothing but 1. So let me write it down. Sine squared plus cosine squared is 1 plus cosine is left here, cosine of theta, divided by, copy down your denominator. Nothing is changing in your denominator. Sine theta, 1 plus cosine theta. Very well. Hey, what do I have here? I have something similar to this. I have A divided by AB, which becomes 1 over B. I can cancel out the common factors. I left with 1 on the numerator. On the denominator, I left with B. It's the same scenario here. I have 1 plus cosine on the numerator, 1 plus cosine on the denominator. I can cancel out the common factor, which becomes 1 divided by sine theta, which is nothing but cosecant theta. Wow, guys, take a look at this. This crazy looking addition between these two fractions is nothing but cosecant. Perfect. So let's see, what do we have here before we go to breakout rooms. This example is saying that use substitution to rewrite this as a function. Guys, for those of you who are going to take calculus later, it is important. It says use substitution. What substitution? X equals to 2 times tangent of theta to rewrite square root of 4 plus x squared as a function of theta. So this is a very common method, converting something to something else using substitution. Okay, let's see. I have square root of 4 plus x squared. Let us write it down. 4 plus x squared. Now, I'm going to do the substitution. The substitution says, well, wherever you see x, use 2 times tangent of theta. Very well, it's not that hard. Let me see. This guy becomes square root, 4 and 4, plus and plus. X now is 2 times tangent theta. 2 times tangent of theta raised to the second power, to the second exponent. Okay, let's go back to algebra. From algebra, we know that if we have A times B to the power n, this becomes A to the n times B to the n. Especially AB to the second power is A squared times B squared. Okay, 2 times tangent of theta. 2 times tangent of theta to the second power, it becomes 2 squared times tangent squared of theta. Becomes 4 times tangent squared of theta. Again, recall that tangent theta to the second power is tangent squared of theta. It is not tangent theta to the second power. They are different from each other. Let us go back here. What do I see? I see a radical. I'm going to copy down the radical. I have 4. I'm going to copy down 4. 2 tangent theta to the second is 4 tangent squared of theta. I already know that. So it is 4 times tangent squared of theta. Can I factor out 4? Of course. Why not? This guy becomes the square root of 4 parenthesis 1 plus tangent squared of theta. Again, from algebra, you can write the square root of 4 as 2. This guy becomes 2 times square root of 1 plus tangent squared of theta. Well, 1 plus tangent squared of theta is secant squared. You already know that. So let's write it down here. One plus tangent squared of theta is secant squared of theta. Substitute that here. This guy becomes 2 times square root of secant squared of theta. But square root of a squared is just a. This is from algebra. If a is positive, am I right? If a is positive. So this guy becomes 2 times secant of theta. Square root of 4 plus x squared by using trig substitution. Again, you're going to see trig substitution in calculus a lot. 4 plus x squared inside the radical is 2 times secant theta. Again, remember that if your expression is positive, the square root is a itself. But if the expression, you have no idea if it's positive or negative, you're going to use plus minus a. Remember these two. Differentiate between these two.